Hi there, in the previous lecture we have learned how to create a single linked list. In this lecture we will learn how to insert a node to the single linked list and how it reflects in the memory. There are three ways to insert new node in an existing single linked list. We can insert a node at the beginning of linked list, we can insert a node after a node in the middle of single linked list, and we can insert a node at the end of single linked list. First, let's look at adding a node at the beginning of single linked list. Let's say we have a sample linked list which is allocated in the memory like this. We want to insert an element of 0 at the beginning of single linked list. The first thing that we are going to do is allocating a random memory in the heap for new node. Then the address of first node of linked list, which is 1 in our case over here, is assigned as the next pointer of newly created node. So the next pointer of 0 over here will be first node of this linked list. Then we assign the address of this newly created node over here to the head, and the connection between head and with this first node over here will be broken. So the reference of head will be newly created node now. So that's it for the insertion of a new element to the beginning of linked list. Let's continue to the next scenario. In this scenario, we want to insert an element in the middle of linked list. As before, we have a linked list in memory like this, and we want to add a new node of 3 to this linked list after 2 over here. As the data in the linked list is not stored in contiguous format, we need to traverse from head to find the given node over here. So to insert this element over here, we need to start from the head and come here and then insert this element over here. Then after reaching this node over here, we need to allocate a random location for this new node and make the next node of the current node as a new node. So the next node of this node over here, which is 2, will be newly created node. And the next node of newly created node will be the next node over here. So in our case it's 4. And with this, the insertion of element in the middle of linked list is completed. So we are just creating the link between these nodes over here. Now let's continue to the next scenario in which we will add a new node at the end of linked list. Here again we have a sample linked list which is allocated in the memory like this. So to add an element at the end of linked list, we need to traverse from first element till the end of this element. So when we reach the last element, so we allocate a location in the memory for this element, then we are updating the next reference of last node to this node, and the tail reference is updated to this node over here. With this, we are adding new node at the end of linked list. So in this video, we have explored what happens in the memory when we add a new node to the linked list in 3 different scenarios. It's obvious that the most efficient way of adding a new element to the linked list is adding an element at the beginning of node, because here relinking is not required and we are not traversing through linked list. But adding an element at the end of linked list is time consuming because we have to traverse through all elements of linked list and then update the reference of last element over here. So this is all for this lecture. Here we have learned what happens in memory when we add new node to the existing linked list. Now in the next lecture, let's look at the algorithm of insertion in single linked list. See you over there.